Do you see that bright spot? That's Henry Draper Extension Catalog 65426b, or Nisaka Pike, Mother Earth exoplanet, photographed by James Webb in the constellation Centaurus, 385 light-years from Earth. Who would have thought that a distant gas giant would instantly overturn astronomers' ideas about the Big Bang, the supposed catastrophic event that started everything we see around us? Did it really happen? Or is it someone's crazy invention that accidentally became the foundation of modern science? Is there an alternative to the Big Bang? And why are scientists increasingly doubting this theory? Honestly, because of James Webb's recent discoveries, astrophysicists are in a state of constant panic. Subscribe. The deeper we delve into studying the universe, observing the evolution of galaxies and stars, the more we realize how little we know about the world around us. For example, KHIP 65426b mercilessly breaks the principles of planetary evolution, showing an abnormally high orbital tilt, unconventional formation scenarios, and the absence of a protoplanetary disk, despite its relatively young age, to top it all off. James Webb drove the final nail into the coffin of traditional ideas about the macrocosm when he discovered rather mature galaxies, where, a priori, they simply shouldn't exist. The observatory, packed with equipment, will operate for at least another couple of decades. What awaits us next if the telescope's discoveries are already baffling us? And what will happen when more advanced successors to James Webb appear? Predicting the future is not our strong suit. However, the Big Bang Theory is increasingly being pushed aside by alternative explanations. Where did everything come from? The most popular is the oscillating universe model. According to this theory, the universe goes through an infinite number of cycles of expansion and contraction. After the global explosion, a catastrophic shockwave occurs, and a long period of expansion begins, but eventually gravitational collapse sets in, meaning the universe gradually contracts. If we take this theory as an axiom, it turns out that the Big Bang is not an exclusive event at all, but rather a routine and ordinary occurrence. Many astrophysicists consider this model and similar ones, such as the Big Bounce, to be attempts to combine gravity and quantum mechanics, which is speculative. But how do we know how accurate the theory is if we don't even know where the doubts about the familiar and comfortable Big Bang Theory originally came from? Why not be satisfied with it and stop looking for questionable alternatives? First of all, the situation is influenced by various anomalies that James Webb, thanks to the super instrument NIRCam, periodically finds in the depths of space. These objects completely destroy cosmological principles, since their properties and behavior do not correspond at all to the standard model. The Big Bang Theory states there can't be mature, old, or dead galaxies in the early universe. But in 2024, ZFUDS 7329, located about 13 billion light-years away from us. During the research, it was found that the process of star formation in this supermassive galaxy ended 800 million years after the Big Bang. This forces us to question the reliability of the traditional cosmological model. Where did the young universe get the strength and energy to create such a massive cluster and then destroy it? What is responsible for gravitational interaction and the formation of galaxies in the macrocosm? In generally accepted theories, one of the components is always dark matter, and although its existence hasn't been proven in Bailey's equations, it's impossible to do without the aforementioned premise. But when James Webb Space Telescope discovered this anomalous galaxy, astronomers had to think hard about it. We're talking about JATES JSZ13, one discovered in 2024. It, like its counterpart, New General Catalog 1052, Dragonfly 2 galaxy, which was recorded in 2018 by scientists from Yale University using the Dragonfly telescope, is experiencing an acute shortage of this mysterious dark substance. The diameter of this unique object, which formed just 330 million years after the Big Bang, is about 2,000 light years. And the mass of JATES Z13-1 is incredible for early galaxies, amounting to about 100 million solar masses. But that's not the most amazing part. According to the traditional model, the presence of dark matter makes up about 27% of the mass of any galaxy, since it plays a key role in its formation. But not in this case. After multiple calculations, the results of which kept changing, astronomers found that the proportion of dark matter in JATES Z13-1 is abnormally low compared to similar objects. To understand the scale of the problem, it's enough to mention that dark matter is considered a kind of framework for the formation of galaxies. Thus, its absence in practice would mean the same as if a person were born without a spine and bones. Sometimes there are even suggestions about the artificial origin of the object. An analog of galaxies with a minimum of dark matter is also the Big Wheel, discovered by James Webb Space Telescope in 2024, a massive object that formed 800 million years after the Big Bang. This galaxy is also spiral-shaped, which is considered impossible under the conditions of the early universe. Which anomalous galaxies are associated with possible technosignatures? The most distant structure at the moment is the HD, one cluster located 13.4 billion light years from Earth, which some consider to be a kind of megastructure of artificial origin. In 2022, the galaxy was discovered by James Webb, and according to preliminary findings, stars in HD 1 are forming at an anomalous rate, more than 100 per year. It is possible that the extraordinary brightness is due to an ancient supermassive black hole, which is absolutely uncharacteristic for the early period of the universe's development. This leads to speculation about a megastructure, a Dyson sphere, or some other structure unknown to us. In any case, the object does not fit into the established theory on which terrestrial cosmology is based. By the way, alternative models formulated by some scientists sometimes turn out to be just as anomalous as the objects we've just talked about. Which one holds the record? The first place among original theories can't be given to a single contender. There are several of them. For example, plasma cosmology. The mechanism of this theory states that the universe was formed without the involvement of the Big Bang or dark matter. So how did it come into existence? Galaxies and other large-scale structures were formed with the help of electromagnetic fields and plasma. The theory leaves a lot of room for imagination, but it's a pity that scientists have overwhelmingly rejected it because it doesn't match key scientific data. Remember the famous Stephen Hawking with his extravagant ideas about, well, back in 1983, he and his colleague James Hartley developed the concept of quantum cosmology. Mathematically, the theory is incredibly complex and it's impossible to test, although the model solves the problem of the initial singularity and is compatible with quantum gravity. The theoretical assumptions of this concept are very interesting, but the lack of empirical tests makes it unlikely. The mechanism of the universe's origin within quantum cosmology describes time behaving like space. The universe spontaneously arises from a quantum state without the involvement of a singularity, and the space-time continuum is closed, like a sphere with no starting point. Why do all these theories not stand up to criticism compared to the Big Bang? After all, many of them sound quite logical, except for the exotic ones. What evidence supports the Big Bang model? The Big Bang, as the dominant theory, has the most theoretical and mathematical evidence, which is why it leads. The main pillars it relies on are redshift, which indicates the expansion of the universe, the cosmic microwave background radiation, and evidence of galaxy evolution. For example, James Webb has repeatedly shown that early galaxies are unstructured, smaller in size, and have a higher rate of star formation. Here's the Cartwheel Galaxy. Isn't it strange? As for the microwave radiation discovered in 1965 by Robert Wilson and Arno Penzias, it is considered to be an echo of the hot phase of the early universe, which in turn is a consequence of the Big Bang. But here lies the main counter-argument against the traditional theory. This is the axis of evil, a super large-scale cosmic anomaly confirmed by observations from many telescopes, including Chandra and the Planck Space Observatory. This is a region where the isotropy of the universe is violated, manifesting itself in the alignment of irregularities present everywhere else in the macrocosm. Scientists are especially alarmed by the cold spot in the constellation Eridanus, an area where the temperature of the cosmic microwave background is much lower than average, and almost no stars are observed in this region. How is this super void connected to the Big Bang theory? Directly, because the model assumes the isotropy of the universe, meaning it is the same in all directions and homogeneous on large scales. This is the basis of the cosmological principle. Therefore, the axis of evil, along with the Eridanus supervoid, seriously undermine the reputation of this theory. A random coincidence here is practically excluded, so the anomaly gains statistical significance. If the axis of evil is real, then the universe may have a preferred direction, or perhaps it is rotating. In either case, the Big Bang theory would need to be reconsidered. If you add to this the anomalous galaxies and planets discovered by James Webb, the threat to the foundation of terrestrial astronomy becomes quite real, as does the panic in the scientific community. At the moment, the axis of evil is a subject of debate since its existence has not been fully proven. We hope for productive work from James Webb, who will shed more light on this mystery in the future. How long will the shaky stability of the cosmological foundation last? Early massive galaxies, the absence of dark matter in certain regions of the universe, as well as the problem of the singularity point as infinitely dense and hot locations where the laws of the universe do not work. Are they capable of destroying what our understanding of the world has been based on for many years? We can bet that it will be some unexpected discovery that will finally pull the ground out from under the theoretical foundation and completely turn classical science upside down. Perhaps it will be irrefutable evidence that we are living here in a simulated universe created by a more advanced civilization. What do you think about this? Well, Earthlings, the video isn't over yet. There's still some truly spectacular episodes ahead. But for me to keep delighting you with all the characters of the universe, I need your feedback. You can express it quite simply. All you need to do is give an electronic like under this video, because we simply don't have any other likes. And continue the phrase, I know. This way you'll let us know that we're moving in the right direction. Don't switch channels.